So 3.10, order of operations and complex fractions. We'll get into complex fractions, but order of operations, hopefully by now, since we've gone over the 4 basic operations, multiplication, division, which do not need common denominators, and then we went over addition and subtraction, which do need common denominators. Since we should be able to do those 4, we should be able to operate on any problem, no matter how big or how many operations there are, with fractions specifically. So just a quick reminder about the order of operations. It's not always PEMDAS, right? So yeah, you do have parentheses first, exponents second, but sometimes the division comes before multiplication because you're always looking from left to right. And the same is true for addition and subtraction. Sometimes the subtraction comes first because it's farther to the left. And it doesn't matter if there's fractions, it doesn't matter if there's negatives. The order of operations always applies to the values. So on a problem like this one, to apply the order of operations, I'm looking at the parentheses first, specifically, and again, one of the main purposes of the order of operations is to make bigger problems, is to help us focus on smaller problems within bigger problems. So 1/4 plus 1/12, I need common denominators on those. I'm just going to use 12. So I multiply the 4 by 3, and the 1, its numerator by 3 as well, making that 3/12. So I got 3/12 plus the 1/12. And in 12ths, 3 plus 1 is 4/12. But this is simplifiable, right? Because 4 and 12 are both divisible by 4, making that 1/3. So rewriting the problem now, because I just simplified everything inside of the parentheses, I got 1/3 times 2/3. Now that was addition inside the parentheses, so we needed those common denominators, but now I'm using multiplication. So I do not need common denominators. They are, but I don't need them to be. Because remember, with multiplication, we simply multiply the numerators and denominators separately. So 1 times 2, the numerators is 2. The denominators, 3 times 3 is 9. Now I would look to simplify this, but 2/9 cannot be simplified. So we should be good, but I'm going to just, again, double check on the calculator. Yeah, so the calculator confirms that this is 2/9. And I can box it in. Alright, problem like this one, very similar. Except this one has the exponent, which hopefully isn't too bad. But again, order of operations allows me to focus on one specific part of the problem instead of the whole thing. So I've got 2/5 plus 1/2, and I need common denominators there. So I multiply the 5 by 2 to get 10, so the 2 by 2 makes that 4/10, because I'm using a common denominator of 10. So I multiply the 2 by 5 and the 1 by 5 as well to make that 5/10. And this is addition. 4 plus 5 is 9, so I got 9/10. And I'll rewrite the problem here, right, with the parentheses and everything else. So we can already see it's slightly simplified, but I got that exponent next because there's no other operations inside the parentheses to do. So I'm looking at the exponents. And 9/10, we'll show the work up here. 9/10 to the power of 2 is just 9/10 times 9/10. Well, from that, 9 times 9 is 81, and 10 times 10 is 100. So now I got 3/8 minus 81/100. So my common denominator, 8 does go into 100. Well, not really evenly, but you could make it work out that way. Just you'd have decimals, which we don't want. So I'm just going to multiply, just so I don't have to find the least common one. I'm just going to multiply the two denominators by each other to give us the common denominator of 800. And yeah, we're using subtraction here. So I'd have to take the 3 times 100 as well, which would be 300. And the 81 would be multiplied by 8, which would be 648. Yeah, so we got 300 minus 648 in the numerator. Give ourselves more space there. So what does that equal? Let's see, this is an 800ths, which probably is going to need to be simplified, but let's find out. 300 minus 648 would be negative 348. Well, both of these, it looks like they should be divisible by 4, but just to make it easier, I'll divide both these by 2. To make, that'd be still negative 174 400. So this is, yeah, still divisible by 2 there. And then we get negative 87 200ths. So it looks like 200 would have worked out as probably the lowest common denominator. Not that I'm worried about that right now, but I got negative 87 200ths. That's already a proper fraction, so I don't need to worry about changing this into a mixed number. We should be good, but let's type this into the calculator just to make sure it works. So again, the calculator has confirmed that by typing that in, that it is negative 87 200ths. All right, now be careful on a problem like this one. This is not 4 3/5, it's 4 times 3/5. So this is not a mixed number, but you guys take 30 seconds, well, take a minute, all right? Take 1 minute and see if you can solve this one. 1 minute, go. Let's take a look at this one. By the order of operations, we do parentheses first, but there's no real operations inside the parentheses. We just got fractions, which could be considered division, right? But that's going to change these into decimals, which we don't want yet. There's a different unit on decimals, so we're not worried about that. Let's keep these as fractions, all right? So I don't worry about the parentheses in this case, but I do look at that exponent of 2, and I need to consider that one. It's 3/5 to the power of 2, so that'd be 3/5 times 3/5. Now again, with fraction multiplication, we're just multiplying the two numerators, which in this case is 3 and 3. 3 times 3 is 9. Multiply the denominators, 5 and 5. 5 times 5 is 25. Now, if you want to keep that in parentheses, you can. But let's look at the rest of this problem. It's negative 9 25ths plus 4 times 3/5. All right, so if I'm looking at this problem, we just did exponents, so I'm looking for multiplication or division from left to right, and there's multiplication right here with 4 times 3/5. Now I'd make that 4 over 1, so I could use fraction multiplication. 4 times 3 is 12, and 1 times 5 is 5. So 12/5 is what that comes out to as an improper fraction. And again, with fraction multiplication, just multiply the numerators and denominators separately. So what do we got now? And when we look at this stuff with the negative right there, it's just a negative of a positive, so I'm just going to make the whole thing negative right there. I don't really need the parentheses. But we're adding now, because we did all the multiplication and division from left to right. So I'm looking for addition or subtraction from left to right, and I see we're using addition, which means I need common denominators. Well, I'm gonna use the common denominator of 25, because I know 5 times 5 is 25. So I'll multiply the 12 by 5 as well to make that 60 25ths. So I got negative 9 25ths plus 60 25ths. So in 25ths, I can take negative 9 plus 60, which is just going to give me 51. Now, this one does not say if it wanted the answer to be a mixed number or an improper fraction. So you could leave it like this if you wanted to. Again, just to make this easier, I'm going to change the, well, I would change the improper fraction into a mixed number with a calculator, which I'll do. So if you wanted to change it into a mixed number because you just really like them so much, 2 and 1/25 would be your mixed number. But again, I'd say it's one or the other because they're equivalent in value. So that brings us to complex fractions. Now, you guys can see where I kind of emphasize this line right here. It won't be so emphasized on the homework just because it's, when putting these into computer programs like I did with this PowerPoint essentially, it just, sometimes it's hard to distinguish where that big fraction line is. But the main thing we want you guys to remember is that complex fractions, which is just one or more fractions inside of a fraction, it's just division of fractions. Okay, so like you can see here, it was a over b over c over d, which really translates into a over b divided by c over d. Now, if we remember division of fractions, we don't actually divide fractions. We end up multiplying the fractions. Okay. So in this case, where it's a over b divided by c over d, it would change to a over b times d over c. So a problem like this one, I would start out, and I've emphasized that middle line there because, again, that's where the division is. I would show this as 1/2 divided by 3/4, which, again, I don't divide fractions, I only multiply them. So we keep the dividend and change the operation and flip or reciprocate the divisor. So I got multiplication right here. I can cross simplify here by dividing the 2 and 4 by 2. So that'd be a 1 there. 4 divided by 2 is 2, which just makes the multiplication easier, right? 1 times 2 is 2 in the numerator. 1 times 3 is 3 in the denominator. Now, having done all this work, you could put this in the calculator by using the fraction button twice. So I got a fraction right there by pushing the fraction button, but if I push it again, it shows that I can have a fraction in the numerator, which was, in this case, 1/2. Now I push down to go into that second fraction, and if I push the fraction again, it's going to allow me to put in that second fraction, which was 3/4. When I push enter, we should get 2/3. So it already simplified the answer for us, which is hopefully what we want. All right, here's a really good problem. And we probably don't like it, just even the way that it looks, right? Like looking at this one, it gives me a bad feeling inside, okay? We don't want you to have that bad feeling. We'd rather you feel good about it. And just remember that the order of operations still applies to a problem like this one. So even if by chance, because I don't think it says usually on quizzes and stuff that to use the order of operations, it would just say simplify. But remember that this is a order of operations problem, okay? So if we consider this as an order of operations problem, that means that I would be focusing strictly on the numerator first. I like to start with the numerator, so 2/3 plus 5/6. So I'll start operating with this. Sorry about that. By finding a common denominator with the 2/3 and the 5/6, which has a common denominator of 6. So I'd have to take 3 and multiply it by 2, and 2 times 2 would be 4. So 4/6 now, plus the 5/6, and we have this all in sixths now. 4 plus 5 is 9. Now I see 9/6 can be simplified, so I will do it by dividing these both by 3. So now this is 3/2 as a fraction. But I need to now that I have fully simplified the numerator, let's look at the denominator and see if we can fully simplify it. So on this one, would have 3/4 minus 7/2. I want the denominator to be 4. So I'll multiply the 7 and the 2 by 2 to make that 14/4. And now I have 3/4 minus 14/4. So in fourths, I can combine these. 3 minus 14 would make that negative 11/4, which cannot be simplified. So I'll just keep it as negative 11/4. Now we are operating with fractions here. So you may see that the 11/4 could be simplified or changed into a mixed number. But it's not necessary that you do that, especially since we're just operating with fractions here, right? So I don't want to show this. And yeah, these are all equal, by the way. I do not want to show this as a complex fraction. I would rather show it as division. So that would be 3/2 divided by negative 11/4. Well, again, I don't divide fractions, I multiply them. So I'm going to keep the dividend the same. Let's change the operation of multiplication and reciprocate that fraction to be 4/11. And you can see, hopefully, just from the reciprocation, why we do not want the mixed number right there. Now, you may notice that the 4 and 2 could simplify. We already did that, so let's say that we didn't notice it, okay? So 3 times 4 is 12, and then 2 times 11 is 22. Don't forget your negative, because there's only one negative. One is odd, so the answer is a negative. And then the last thing we're going to want to do on this is to simplify this, which it can. Both of these are even, so I know they're at least divisible by 2. Negative 6/11, and that should be complete. But again, going back to the calculator, we should be able to type this in, even though it has fractions in fractions, and we're operating with fractions there. So let's type it in. The calculator spits out that negative 6/11. It's already simplified, and I feel pretty good about that answer now.